Start, sir.
Hello, course participants of Vibrations of Structures. Welcome to this third live session of the course. In this live session, we are going to take your questions and your doubts, difficulties that you might be facing. This is Anirvan DasGupta from the Department of Mechanical Engineering at IIT Kharagpur. Please use the live chat to ask questions, put forward your doubts. This is our 11th week, I think, running. We'll be soon completing this course. And let me just recapitulate what we have discussed since our last live session, which was roughly in the 8th week, I suppose, 7th or 8th week. We have discussed the dynamics of, we were discussing dynamics of beams when we last met. There were, in the 8th week, we had discussed some special problems in beam dynamics or beam vibrations. For example, we had looked at the conversion of inhomogeneous problem to a homogeneous problem, problems of beams with end forces, determining the natural frequency and buckling load, especially the buckling load using the natural frequency, its variation with axial load, and how you can actually calculate the buckling load without destroying the beam. Experimentally, we can find out these things we had discussed. Then we had looked at dynamics of beams with end forces, follower forces, and things like that. So that was in week 8. And before that, we had covered various kinds of beam kinematics. For example, Rayleigh beam, Euler-Bernoulli beam, Timoshenko beam. These kinds of beam models we had discussed. Then in the 9th week, we had discussed the dynamics of curved beams. These are very important for arches and rings, that study the dynamics of rings. And we had, in fact, discussed the dynamics of rings, calculated the natural frequencies, the modes, and we had looked at very special kinds of motion that the ring can show up, where the particles can actually move along the center line. And we had found, we had then discussed about approximate methods for arches using the Ritz method. We looked at various boundary conditions and chosen our expansion appropriately, and looked at the dynamics of arches. We had calculated the natural frequencies and the mode shapes. So that was covered in the 9th week. In the 10th week, we started with the discussion of dynamics of membranes. We looked at the vibrations of rectangular membranes, then circular membranes, and then here we came across the concept of degeneracy, modal degeneracy. What are degenerate modes? Degenerate modes are modes which have the same natural frequency, but the modes, mode shapes, the eigenfunctions are orthogonal. Orthogonal eigenfunctions having the same natural frequency or circular natural frequency. We had discussed degenerate modes. In the case of circular membranes, which are quite interesting. We have the solutions in terms of the Bessel functions, and for a complete circular membrane, we have the Bessel function of the first kind, because the Bessel function of the second kind has a logarithmic singularity at the center. But that will be included, that term of Bessel function of second kind will be included in if you want to discuss the case of an annular membrane, for example. So that was the 10th week. In the present week, we are discussing the dynamics of plates. The kinematics of plates is quite complex. We had discussed about force and moment resultants by integrating the stresses over the thickness. And in terms of these, we had written out the equilibrium equations. We'll be discussing vibration of rectangular plates and then vibrations of circular plates. And in the final week, we are going to look at some special problems in plate vibration. For example, in the normal course, we have discussed plates which are somehow fixed at the boundary. They may be simply supported, they may be clamped. But we will discuss problems like if you support a plate by a circle. So for example, a rectangular plate having a circular support inside it, centrally located, of course. Then how do we solve the dynamics? How do we calculate the eigenfrequency approximately, let's say, using Ritz method? So these kinds of problems we are going to look at. Okay. So based on this, if you have questions, queries, or comments, especially on the assignments, they are most welcome. We have one question from Mr. Abhinash Kormakar. He is asking, sir, please provide courses on analysis softwares. Yes, this course, vibrations of structures, the calculations are quite complex, and I understand that doing these kinds of calculations again and again can be quite cumbersome. In very many situations, what we do is we use some symbolic toolboxes or symbolic manipulation softwares. Like you can use Mathematica or Maple and do this calculation symbolically. So that is definitely a challenge. Doing these calculations, especially when you have these integrals to evaluate, then it really becomes quite cumbersome sometimes. And therefore, some softwares, use of some softwares would be very good. But in this course, we have not really discussed these softwares, but I would recommend that you explore softwares like Mathematica, which is rather than going to some finite element softwares in which you do not have any control, you cannot see what is happening inside. But in softwares like Mathematica or Maple, you can do this computation step by step according to your way of thinking, the way you have thought about it, and you can get a good feel of the problem. Therefore, I would recommend that. But in this course, unfortunately, we do not have scope for introducing softwares. Okay, Akib Zargar, he has commented that your speed is too slow, but content is excellent. So thank you for the comment. Uh, See, these calculations, as you can see and very well understand that these calculations are quite complex, and it is very important that students understand the steps. In that respect, I have tried to be as slow as possible so that you can uh, even write down, understand, and follow the material as we discuss in the video. So please, I hope I am able to answer your queries. Please comment if you are not satisfied, then we can discuss further. So Apuit Zargar, please let me know. Please put down your comments in the chat box so that we can discuss. Specifically, I would like to know your comments on the assignments. What, how do you feel is the level of the assignments? Are they becoming too difficult or too easy? This would be very helpful to us in setting the level of assignments in future. So please post your comments either in the chat box, or you can also post in the Google spreadsheet which has been shared with you. So Avinash Karmakar, have I answered your question? Please let me know. If you have anything more to discuss, please post your comments in the chat box, or you share your comments with the Google spreadsheet. I am scanning both of them and would like to discuss things which you are finding difficult, or if you have something, some comments, some feedback. I have mentioned in the previous live session as well about the final question paper. Many of you have registered to take the test. The question paper will have 4 parts. The first part would be recall type questions directly from the videos that you have watched. The second part would be questions based on your assignments. And the third and fourth part, which are kind of merged, they are new questions. Everything is MCQ. They are new questions, and we have not put many things which require to memorize. We have tried to minimize on memorization of the material. You have to develop some understanding of how let's say the kinetic energy, potential energy, these things are calculated, and based on that we are going to evaluate. Therefore, this third and fourth parts of the test would be MCQ based and based on new kinds of questions, but of course not very different from what you have faced in the assignments and the videos. Right. Okay. Rajan Rahul has asked this question. It's an important question, sir. Is there any open source software for symbolic computation? Maple and Mathematica are paid sources. It's correct. You have to purchase Mathematica, for example. You have to purchase, and they are not very cheap. Um, I know people who are using symbolic toolboxes in Python, uh, but I am not. I have not worked on that, but I am aware that people are trying to develop symbolic toolboxes for computation using Python, but but it's actually this symbolic toolboxes are proprietary things, and most of the time you'll have to purchase these. But it would be very good if you have access to a symbolic computation software. Then all these calculations become very easy, and everything is in your control, in the sense that uh, if you use a finite element software package, for example, then you do not know what is happening inside the meshing and things like that, and that gets quite complex. But when you do it using the symbolic softwares, then you can do in the steps as you have learned them. That is very important, and that gives you a very good grip on the problem. Particularly if you use Ritz method, if you can do those symbolic integrations, computations, then you can study the effect of various parameters symbolically. You don't have to do a numerical computation. And in numerical computations, most of the time, you will not be able to detect certain things because it's all numerical. You have to keep changing these parameter values and studying, let's say, the variation of natural frequency or whether there are some instabilities. I mean, but in symbolic calculations, you can detect them in terms of these unknown parameters. I hope, Rajan, Rahul, I have answered your questions. Please keep posting. So please post your comments, questions, feedback on the chat box, and we'll try to answer them, especially if you have any comments uh, on the assignments. Of course, you can also post your questions. If you have detailed questions about these assignments or any particular problem, then you can post it in the forum, and we will get back to you with more detailed answers. Okay, Rajan, Rahul, seems I have been able to answer. Please post your comments or questions. To answer one of the previous comments of Avinash Karmakar, courses on analysis softwares actually, and there are other questions also on softwares, because in this course it is when you try to solve some really practical problems, then the computations can be quite high. And in that scenario, having a software, especially symbolic manipulation or symbolic computation software, would be very good. I am sure that there are other courses which discuss softwares, but symbolic toolboxes or symbolic softwares. By the way, MATLAB also has a symbolic toolbox, but again, you'll have to purchase MATLAB. Therefore, having a software which can do symbolic computation is very good for doing practical problems, or problems which are more complicated than what we have discussed. We have discussed the basics of how to model, let's say, a beam. But now you can go ahead and analyze, for example, frames. And we have discussed analysis of frames, how we connect two beams to form a frame, and look at the boundary conditions, the connection conditions at the connection, the compatibility, and using that we can solve problems which are relevant to applications. But for such problems, we need help of some computational resource. So please post your comments, your questions, queries, or doubts. I would like to have feedback from any faculty members who might be present here. If you are present, please let me know about how relevant this course is for your students. If you are teaching this course, if this course has been useful, then I would like to have your feedback. If you are teaching this course, or some of your students are doing this course, and how are their responses to this course, and uh, how much they are learning from this, or if there is any difficulty they are facing in following the course or the assignments, please let me know. So please keep posting your comments on the chat box, and we will discuss them. So if there are any teachers who are in this live session with us, to faculty members, so please let me know your comments, your feedback about how your students are using this course, or if they are going through it, what is their response, how are they finding the assignments. So please let us know. In case you have more detailed questions, then you can also post in the forum and we'll get back to you. If you would like to know anything about the test, I have already given you an overview of the final exam. If you have any other questions or doubts regarding that, so please post your comments in the chat box. Okay, I think if you do not have further questions or feedback or queries, doubts, then maybe we can close this. But our forum is always open. Please post your comments or feedback in the forum, and let us know if you are facing any difficulty, any other comments that you might have, any difficulties or doubts. We will discuss it on the forum, so that also helps other students. Uh, Maybe we can right now close this session. I would like to thank all of you for your participation, and I also thank the staff of the NPTEL office who have made this live session possible. So with that, I think we will close this live session.